Okay, so today we will do about the exclusive preparation of aldehyde. So let's start. Last video was about the preparation of both aldehyde and ketone, but this video is exclusively for the preparation of aldehyde or the methods which will only work for the preparation of aldehydes. Okay, so for that naming reaction begins from here. Okay, so preparation of aldehyde. Okay, the first reaction which comes here is Rosenman reaction. ROSENMUND reaction. Okay, the first reaction which comes here is the Rosenman reaction. So what happens in Rosenman reaction? Let us check it out. Okay, in Rosenman reaction we take an acid halide. Okay, and treat it with Lindlar catalyst. I am coming to what is Lindlar catalyst later on. LINDLAR CT for catalyst. Okay, so Lindlar catalyst. After that I get my required product or aldehyde. Okay, now what is this Lindlar catalyst? Lindlar catalyst is, okay, I'm doing it freshly. Okay, Lindlar catalyst. What is my Lindlar catalyst? Okay, Lindlar catalyst is nothing but it is PD or palladium in presence of BaSO4 poisoned by sulfur. POISONED poisoned by sulfur. Okay, now let us check it out. Check out the reaction. What is happening? I will take nothing but an acid halide. It can be quinoline also. Okay, in presence of Lindlar catalyst, you can also write it as quinoline. QUINOLINE. Okay, and now let's check it out. What is the reaction in brief or the framework of the reaction? It is R C double bond O Cl. This is my acid halide. Okay, acid halide, when you are treating it with acid halide, when you are treating it with the Lindlar catalyst, LINDLAR catalyst, when you are treating it with the Lindlar catalyst, it gives aldehyde R C double bond O R, and this R is coming out with hydrogen, which is this chlorine is coming out with an hydrogen, which is my HCl. Okay, let's take an example. Okay, let us take the example of ethanoyl chloride. Okay, what is the ethanol chloride? Is about CH3 C double bonded O single bonded Cl. On treating it with the same Lindlar catalyst and giving it a common bit for repetition of same things, we get CH3 double bonded O, CH double bonded O. What is this now? I am getting, this is my acetaldehyde. See, this is the aldehyde group. Okay, this is called acetaldehyde. Okay, plus HCl. HCl is the outcome. I have already mentioned it here. Okay, so in presence of sulfur, you have to do it like this. Means poison with sulfur means the effect of that PD and BaSO4 are reduced with the help of sulfur. I take another example. I take another example like this. Okay, let's check it out what is happening now. Let's take this. Mm-hmm. Same thing, linear catalyst. For this, I am just writing it in presence of H2. Okay, for better understanding. Otherwise, H2 is always taken from the atmosphere. Okay. Now, what happens here is this Cl will come out. Linear catalyst. I am writing at Lc. This H will come out with C, and one H will go here. So aldehyde will form, or benzaldehyde, which is an aldehyde, with an aromatic aldehyde. Benzaldehyde will be formed. Okay. So what is the structure of benzaldehyde? Benzaldehyde looks like this: C double bonded O, single bonded H plus HCl. Okay. I hope the workplace is visible now. Okay. Now for this, you have to remember that this thing, C double bonded O, so you can never prepare this method, or this is called formyl chloride, like formyl chloride. Formyl chloride can never be prepared by this method because this formyl chloride is highly unstable. Okay. Now coming to the next reaction, which is the Stephens reaction. Another name reaction. We have already completed the Rosenman reaction. It was all up to this. So I am just giving out a brief to you about the Rosenman reaction. What is happening in Rosenman reaction? We take an acid halide, means RC double bond OCl. We are giving it or reacting it with the linear catalyst, which means the BaSO4 in presence of um, PD or the lead. Okay, BaSO4 in presence of PD or the lead, poisoned by sulfur. It is called the linear catalyst. It can be also called as quinoline, QUINOLINE. It gives RC double bonded OR, means where R is alkyl group. Okay, where R is alkyl group. Okay, I'm sorry, this is H. Okay, where R is alkyl group. This is forming an aldehyde along with one HCl. Okay. Next, I discuss about some example. I'm discussing this in detail. This is my acid halide. See, this is my halogen, and this is the acidic structure, right? This acid halide, when I'm reacting with linear catalyst LC, what is formed? This thing is formed. This is my benzaldehyde, and another byproduct is formed in this process, which is called HCl. Okay. Now I will also said that formyl chloride or HC double bonded OCl can never be prepared by Rosenman reaction because formyl chloride is highly unstable thing. Okay. Now next I will come to back again, and now I will discuss about the Stephens reaction, which is the method for the preparation, means another method for the preparation of aldehyde, rather exclusive method for the preparation of aldehyde. Okay. So for that, I clear out my space. Okay. This is the exclusive reaction for the preparation of aldehyde. Okay. I will discuss about Stephens reaction. Stephens reaction. Okay. What is Stephens reaction all about? Here we take nitride. Okay. Alkyl nitride. Okay. RC triple bonded N. I'm sorry. I pick it with SnCl2 in presence of HCl. Okay. And as a result of this, I get CH or aldehyde. I'm not getting this directly, but I'm getting a late product here or the intermediate product here, which is called imine. Okay, imine looks like this: R C H double bonded NH. Okay, this imine on hydrolysis in presence of water in acidic medium. Okay, this NH3 is coming. NH is coming out as ammonia. NH3, and I'm getting my aldehyde RCH. This is aldehyde. Okay, let's study the mechanism. Let's study one example and then we will come to mechanism of this reaction. Okay, so what happening here, let me take ethane nitrile here. Okay, if this is my ethane nitrile, see triple bonded in this ethane nitrile, when I treat it with HNCl2. This ethane nitrile, when I am getting an action with doing an action with HNCl2, imine is from CH3, CH double bonded in H. This is my imine, INE. Imine is from this imine on acidic hydrolysis in H plus H2O. I am getting another product which is called aldehyde, CH3CH. Okay, this is my aldehyde, and as an outcome I am getting ammonia. Okay, now let's study the mechanism of this reaction. Okay, let's see what's happening here. There are some space. I will discussing Stefan's reaction. Okay. In Stefan's reaction, I will now discuss about the mechanism of the reaction. Okay. Mechanism. Okay. Now, what is happening in the mechanism? Now, we have to keep in mind this SnCl2. When I take it with HCl plus HCl, it is becoming SnCl4 plus 2H plus. Okay. SnCl4 plus 2H plus. You have to keep this thing in mind. Okay. Now this SnCl2 is getting oxidized here. Okay. Sn2 plus. Okay. It gives to Sn4 plus. It is getting oxidized here. So it has plus 2 electron minus here, right? Okay. So up to this was my part 1. Okay. Now I will take my nitrile part or the alkyl nitrile part. Okay. So let me take ethyl nitrate. Okay. C3C triple bonded in. Okay. I am taking CH3C triple bonded in. Okay. This is my ethyl nitrile. This ethyl nitrile, when I am this ethyl nitrile will react with this 2 electron. Okay. Now this is a pi bond, right? Pi bond, we know it can be opened, means it moves around, right? Okay. So this bond will open. Okay. This electron will shift towards this side, so this will get a negative charge. So this electron, gets shifted here. Okay. So this electron is getting shifted here, right? So this carbon will also get a negative charge. So will also coming here. So this carbon will also get a negative charge or 2 negative charge, right? So let's see what's happening. Ca3, C. This carbon is getting 1 2 so I will represent it like this: negative charge and then double bonded. And this bond is opening, so double bonded, and this two electrons are coming here, so I am writing this like this. Okay, now this I took 2H plus. Okay, 2H plus, and this H plus, we know it's positively charged, so they are coming and sitting here. Okay, CH3, C, double bonded and single bonded H, and here also single bonded H. This is imine. Ultimately, I got my imine. Okay, clear up to this much? Now, this was a part 2. This was part 2 of my mechanism. Imine is formed. Okay. Now what I am doing acidic hydrolysis of imine. Okay. Let us draw now part 3. Okay. We will do acidic hydrolysis of imine. Now what was the structure of my imine? My imine looked quite a bit like this. Sorry. My imine was like this: CH, double bonded NH. This was my imine, right? Now this is also a pi bond, so this will shift here again like the previous step. So a negative charge will come here, right? And positive charge will also come here. Now in here, what we're doing is we are doing acidic hydrolysis. Okay, H plus. So acidic hydrolysis means water is breaking down as into H into OH. Okay, this OH is negative and this H plus is positive. So we know this H will come here like this, right? Okay, and this OH, this OH will come here. Okay, now let's write what is being formed. CH3, CH, OH, my single bonded NH2. Okay, happy? Up to this much clear? Now. This NH2 is a very strong leaving group. Now what is happening here is this NH2 will open up, create a bond here. Okay, get a minus charge. Now to balance the minus charge, the carbon is also getting a plus charge, right? Now this hydrogen is saying, okay, you take my plus charge, I am also getting a positive charge here. I'm also getting a positive charge here. You keep your electron, I am getting a positive charge here, I am forming NH3. Okay, so this hydrogen is giving one electron here and going away as NH3. So my NH3 is formed as a byproduct. Okay, so NH3 is formed as a byproduct. Now what I am getting is, see, this electron is shifted to oxygen, right? So oxygen will form a double bond, CH, double bonded O. Or we can write it as CH3, C, double bonded O, single bonded H, or acetaldehyde. Clear to this much? This was about the preparation of acetaldehyde from the Stephen's reaction. Now we will come to another portion, which is the most vital thing, or the very magical thing, magical essence, you can say. Okay, like pixie dust or like that essence or elixir, which is the dival H, or you can call it as dihydroxy aluminum diisobutyl aluminum hydroxide. Okay, so let's see what the magical thing dival H can do. Okay, let's see. What is dival H able to do. Let's see. Dival H, isobutyl aluminum hydroxide. Diisobutyl aluminum hydroxide. Okay. Let's see what divalent is able to do. We take acid halide, RC double bond O Cl will give divalent. Okay. We get a nitrile with double bond H will give divalent. Lastly, we will take ketone. Okay. RC double bonded O, single bonded OR, and will get divalent. Now I have mentioned earlier that this is a magical thing which will convert all of these three things. Okay, all of these three things will be converted to this. I'm drawing it down to accommodate RC double bonded OH. What is this? This is aldehyde. See, this is a magical thing. Okay, when you react divalent with some acid halide, when you react divalent with some acid halide, this thing, or may it be your nitrile, or may it be your ketone, RC double bonded OR, aldehyde is being produced. So I called it as a magical product. Okay. Now, this was about the preparation of aldehyde. Now, keeping up to this much, next day, in this next class, I will discuss about the preparation of benzaldehyde. We will study about Ketard's reaction and Betterman Koch reaction. Okay, till then, bye.